In this video, you're going to learn how to draw some basic Lewis structures for different covalent compounds. Follow along on the covalent bonding practice classwork if you have it. For part 1 on that classwork, it's just a brief review of the exceptions to the octet rule. So this is a reminder. All atoms want 8 valence electrons. So they want to gain enough electrons to have 8 surrounding it. However, there are 2 exceptions. Hydrogen only wants 2, and that's because it's in the first shell, and only 2 electrons can go in the first shell. And boron wants 6. And that's because boron only has 3 valence electrons, so it can only form 3 bonds, which would be a total of 6 electrons. We're going to start by drawing. We're going to start drawing these structures. So the first one is BH3. The first step when drawing these structures is to count your total number of valence electrons. So boron has 3 valence electrons, and we can just look at the periodic table and see that boron is in the 3rd group, so it has 3 valence electrons. Hydrogen has 1 valence electron. However, we have 3 hydrogens. So since we have 3 hydrogens, that's like saying we have 3 1-valence electrons. So each hydrogen brings 1 valence electron to the table. So our total number of valence electrons is 3 from boron and then 1 from each hydrogen. So that's 6 total electrons. With that in mind, we can start drawing our structure. The next thing we need to do, the next step, is to determine our central atom. This is the atom that is going to form the most bonds and be in the center of our structure. There are a couple ways to identify this. The first way is by seeing which element we have fewer of. So notice we only have 1 boron, but we have 3 hydrogens. So in this case, boron is going to be in the center. So now we can start drawing our structure. We put boron in the center, we put the 3 hydrogens around it, and we connect everything with a bond. The next thing we need to do is we need to determine if we need to draw any more bonds or any dots to represent electrons. So first we need to count what we've drawn. So we've drawn 2 electrons here, 4, 6. So that's a total of 6 electrons, and we only have 6 electrons. So we can't even draw any more electrons because we don't have any. So we need to make sure that this structure is correct. So we're going to check every single atom and make sure that they are all stable. So hydrogen needs a total of 2 electrons, and it is touching this 1 bond, and in that bond there are 2 electrons. In every bond there are 2 electrons, so this hydrogen does have 2 electrons. It's good to go. Boron needs a total of 6 electrons, and it has 2, 4, 6 surrounding it. So it's also good to go. Our hydrogen to the right needs 2 electrons, and it has 1 bond, so that's 2 electrons, and our hydrogen below it also has 1 bond, which is 2 electrons. So this is our structure. We have boron in the middle, bonded to 3 hydrogens.